Hello and welcome to the Bluebell.tv YouTube channel. My name is Anil Palmer. This is the third in a series of shorts designed to help understand some of the fundamentals of broadcast fibre optics and fibre optic systems in general. Today we will be looking at single mode and multi-mode fibre, how to tell the difference between the two, their constructions and applications. Good to have you here, let's get started. In the last two shows we looked at connector types and physical connections. We covered ST, SC, FC, LC and E2000 connectors, and in the second show we looked at PC and APC ferrules. Two major things here: all these connector types with the exception of E2000 are available in multi-mode format, and there is no such thing as APC multi-mode connectors. Multi-mode, a lot of people make the mistake of thinking that multi-mode fibre is another word for multi-strand fibre cable. Well, it's not. And single mode fibre is not a single strand of fibre. Multi-mode is named so because the light injected into it takes multiple paths down the fibre. Single mode is called single mode because the light takes a single path down the length of the fibre. Don't worry, all will become clear. But first we need to delve into a bit of science. Fact 1. Multi-mode fibre is either 50 or 62.5 microns in diameter. It's a fat pipe in comparison to single mode fibre at only 9 microns diameter. Fact 2. LEDs emit a broad spectrum of light and lasers emit a very narrow spectrum of light. Fact 3. LEDs are way cheaper than lasers. Armed with these three facts, we can now go forward to the next step. Lining an LED up with a fat pipe, multi-mode fibre, is easy and cheap to do so. Lining up a laser with a single mode fibre is difficult and therefore more expensive. The diameter of the active glass is way smaller. So, if you use an LED to send data down a fibre, the wavelengths at the lower end of the spectrum diffract at different angles to the ones at the upper end of the spectrum. So the light energy, and therefore the data, takes different paths down the length of the fibre. Different paths, multiple modes, therefore multi-mode. With single mode fibre, the laser spectrum is very narrow and could be considered a single wavelength, so it takes a single path or single mode down the length of the fibre. Right, the last bit of science. We have the multi-mode system with its broad spectrum of wavelengths reflecting and refracting along the length of the fibre, jangling away there. And we have the single mode system with its one wavelength serenely progressing down the fibre. Which one do you think will go down the fibre the furthest? Yep, you guessed it, the single mode one. It's a more concentrated beam of light and doesn't waste as much energy as the multi-mode system, and so will go the farthest. For reference, using Bluebell optical conversion equipment, an SDI signal on multi-mode fibre will travel about 2.5 kilometers, whereas the same signal on a single mode system can achieve distances over 70 kilometers, a stark difference. And lastly, to be able to recognize the difference between single mode and multi-mode fibres, you will need to know the following. The jacket of a multi-mode patch cord is either grey, orange or aqua, a sort of blue colour, and single mode patch cords have a yellow jacket. And on bundles of fibres it will normally say 62.5/125 microns or 50/125 microns somewhere along the sheath for multi-mode fibre, and 9/125 microns for single mode. The 125 bit is the outer diameter of the primary coated fibre, which is in the same for single mode and multi-mode fibre. Okay, that's it. Now you know. I will leave you with a recap of the science. If you found this useful, then hit the like button below and don't forget to subscribe to the Bluebell.tv YouTube channel. And join us next time when we will be dealing with cleanliness, and we will be looking through the microscope at what happens when a fibre connector is exposed to the elements. Thanks for watching, and remember, keep it clean.